Welcome everyone to the lab 2. So in this lab, we are going to see how to work with iVerilog and GTK Wave. So we will go to our design folder. Verilog files is the folder which contains all our design files. And I'm going to load the design in iVerilog. So how do I do that? So first let me walk you through this Verilog files folder. So here you're going to see lot of file names, lot of files, and you're going to see lot of files starting with tb underscore some name. So for every file here, you're going to see a associated tb. Say for example, there's a bad latch, you will see a tb underscore bad latch. For a good mux, you will see tb underscore good mux. So this files and the associated tb have a 1:1 correspondence. Okay, so let us load a mux into the simulator. So I'm going to load iVerilog is the command to load iVerilog, and I need to give the design name. The design name I'm going to load is goodmux.v, and I need to give the test bench also. This is the associated test bench. So whatever is your design name, tb underscore that is going to be your test bench name. Okay. Okay. Now you will see a file called a.out getting created here. So what we are going to do is we are going to execute this a.out file. When you execute this a.out, it is going to dump the VCD file. So this is what we discussed in the introduction to Verilog, iVerilog presentation also, that the output of the simulator will be a VCD file. Okay. Now this VCD file, I'm going to load it in my simulator. GTK wave is the command to launch the waveform viewer, and I'm going to give this VCD file as the input to it. So you will see a waveform opening like this. So here you are going to see TB, the test bench. Within the test bench, we have unit under test. That's what is UUT. We will see the inputs. We can drag and drop the inputs here. Just drag and drop the inputs from here. Drag and drop the output. And please note this. This is for fitting the waveform in the screen, because I have run my simulation for a lot of time. If you see, the simulator is working on very small time scale call of 1 picoseconds, and I have run my simulation for almost 300 nanosecond, which is very large time. So you will not be able to see the entire observation in single window. So what we do is we just click this zoom fit to ensure that you are viewing the entire waveform from beginning to the end. Let's say you want to zoom on particular region, you click on that region and then zoom into it, or you can zoom out of it. Now let's say you want to look for some transition on the signal, select the signal and use this. It will look for the transition. This arrow will look for all the forward transitions. This will trace the transitions in the backward direction. So it will trace all the transitions. So if I want to trace all the transitions on this signal, I can use this. Select the signal and look for the transitions. This will be very useful for evaluating the designs. And now we have implemented a multiplexer in the design. So let's see. When my select line is 0, the output is following the I0. When my select line is 0, the output is following the input 0. When my select line is 1, kindly note my I1 toggled here, but there is no change in my Y. Y is following my I0 because select line is 0. Here my select line became 1, and from here onwards my output is following my I1. So I1 is going low here, it's going low here. In the meantime here, my select changed again to 0. So my output starts following my input 0. Okay. So this is how we will load the design and we will check its functionality.